In this training byte, we will explore how to modify the trace block that we had created in the previous training byte. Note that these are ideal trace elements, and as such, provide a great way to do planning and pre-layout analysis, but should be replaced with extracted S parameters from the system once the board has been routed. As always, for more detailed instructions, please go to support.cadence.com, where you can access the lab and training course that will guide you through the Security Topology Workbench tool with System SI for parallel bus and serial link analysis. Start by double-clicking on the trace block to open the Edit Properties pane. Click on the Trace Editor button, which will open the Trace Editor form. Note that the default trace topology is that of a microstrip, which is seen by the cross-section preview. We will change this topology to a strip line. Click on the template icon to open the template form. Select Strip Line from the pull-down menu. Ensure that the Update Stackup checkbox is checked. Enter 11 for signal trace number, 5 for the signal width, 15 for the spacing, 1 for trace thickness, and 4 for substrate heights H1 and H2. Change the thickness of the upper and lower reference planes to 1. Change the conductor layers, the top, bottom and center layers, to copper under the Metal Materials pull-down menu. Change the dielectric layers, the second and fourth layers, to FR4 under the Dielectric Materials pull-down menu. To calculate the various transmission line parameters, including characteristic impedance, click on the Calculate T-line parameters icon. This will open the T-line results tab, which will show the characteristic impedances, delays, and other parameters. Save the trace block as parallel_bus. To view more detailed results, click on the Generate W Element Model icon. The Trace Editor form should close. Click on the View Subcircuit button to view the W Element Model. The W Element Model will return a RLGC model with 6 terms, L0, C0, R0, G0, RS, and GD. There will be a top diagonal on each term that has identical values. This self-term on the matrix is the characteristic circuit element value. The other terms are all coupling terms between the 11 traces that were designed in the trace editor form. The final portion of this training byte is to modify the names of the traces in the trace block to help connect this block to the controller block and the tuning block. Start by clicking on the line that is sticking out on the left of the trace block. Be sure to click on the line and not the ball. Clicking on the ball will attempt to connect the blocks. Replace the net name A with DQ0, and repeat this process for B through H, with DQ2 through DQ7, respectively. Replace net names I and J with LDQS and LDQS hash, respectively. Repeat this same process with the line at the connection port to the right of the trace block. This concludes the setup and generation of the ideal transmission line element. Please refer to the additional training bytes in this channel to continue learning about the Security Topology Workbench tool with System SI.